Hi, I'm Honi Sanders. I started as a postdoc with Matt Wilson in neuroscience and Sam Gershman in modeling. Started a couple months ago. So the project that I'm going to be working on is about context identification in the hippocampus. Context identification is very important. Instead of trying to represent the interaction of all the possible cues and all of the possible behaviors that you should do, you can instead identify a context and then have a relatively simple rule set that you can apply to guide your behavior. It seems that the hippocampus, in addition to its well-known function in the creation of episodic memory, also recently has been recognized with the Nobel Prize for the discovery of place cells in the hippocampus. And basically the idea is that individual neurons have individual parts of an environment in which they respond. You can see here heat maps of the firing rate of the animal, of a given neuron in each location, and you can see different neurons have different parts of the environment in which they respond. And now if you put the animal into a different environment, the representation is totally uncorrelated. Place cells will still respond, but the location at which they respond is totally different. So there's, you can see in the neural firing, you can see a direct correlate of what context the animal thinks that it's in. But the question is, how does the animal decide what context it's in? There's no neon light that says context A, context B. It has to be able to infer from the stimuli that it's observing and also given its past experience. So there have been many experiments that have tried to look at this, manipulate cues, maybe rotate the environment, see how the animal responds, whether it thinks it's the same environment or not. And there's relatively complicated results, often seemingly contradictory results. So here's where we can look to cognitive modeling for framework. So Bayesian nonparametric clustering has been used. So first of all, it's an algorithm for clustering observations when you're not given how many clusters you have beforehand or the cluster identities. And it's been used to explain things like human categorization. So perhaps rats are also doing this when they identify which context they're in. And since as a probabilistic method, it actually represents the distribution as fully as possible. It doesn't, instead of, say, trying to represent what the true context is and then seeing how distant an observation is from that, you actually represent the entire distribution. And this allows for recapitulation of a lot of the experimental observations we see. For example, determining which cues are relevant for identifying context. Since it's probabilistic, you can represent your level of certainty, and also you can represent how experience plays into this whole process. So my plan is I'm building a model and then going to do experiments based on this. At this point, the model is able to recapitulate this experience dependence, which explains previously unexplained experimental results, which I can talk about more if you ask in person.